Okay, first a quick word about how the Faraday's disc work. So a Faraday's disc is just a metal disc that's spinning round and round and round in a magnetic field. So if you think of the flux captured by this area, then no matter how we spin this disc, the flux captured by this disc is the same. So our conclusion will be that there will be no induced EMF, there will be no eddy currents, and nothing should be happening. And that's the correct conclusion. If you tap 2 points on the circumference of this disc, you will not be able to measure any EMF. But if you consider this metal disc as being made up of many slices of wires, like the spokes on the bicycle wheel, then you realize that each of these is a wire, and as the disc is spun around, these are wires that are cutting the magnetic field lines. So we know that there's going to be induced EMF across the ends of this wire, right? Which means there's actually an induced EMF across the center of the disc and the circumference of the disc. Alright, so the Faraday's disc will have an induced EMF, but you must know where to tap it. You must tap the two ends of the wire, which is at the center of the disc and the circumference of the disc. Okay, let's suppose that we got an induced EMF, and so if this is 0 volts at the center of the disc, and just for convenience, let's say we got 6 volts at the circumference of the disc. So if you tap between these 2 points, you get 6 volts. If you tap somewhere in the middle, then you get something that's between 0 and 6 volts. Alright? But the thing is this, you can go in any direction. Is always going to go from 0 to 6 volts. 0 to 6 volts, 0 to 6 volts, 0 to 6 volts. So if you tap between these 2 points, of course you get 0 volts across, because it's 6 volts here and 6 volts here. If you tap somewhere at the middle here, and also somewhere at the middle here, same distance from the center, then the potential here and the potential here should be exactly the same. So again, there will be no potential difference between these 2 points. Alright, so that's it. Ta-ta!